my name is Mitchell Heritage. In the discussion about to take place, we'll be highlighting the current offshore diving data capturing systems and techniques, and be exploring the potential enhancements and effects sensor node technologies and 3D printers could have on the industry. Hey Paul.
Hey Mitch, how you doing?
I'm fine, thank you. Thanks for being interviewed by me today.
Oh, my pleasure.
Would you mind outlining the activities on an average inspection dive?
Yeah, I mean, generalistic. Obviously, you can't identify each individual one. We'll be here for quite a while. But on general, if we're doing part of an inspection campaign, which is scheduled in, so every certain amount of years we'll inspect most of the subsea structures. The process we go through is we start by general cleaning, and we'll use a high pressure water jet normally to clean off marine growth in the area we're going to be inspecting. And then what we'll do is we'll use a grip blasting machine, and we'll grip blast, which basically removes all paint. It can remove a certain amount of marine growth as well, remove the paint and leave bare matte metal so it's not shiny, so it's fit for inspection. And then what we'll do is a general visual inspection of the area that we're going to inspect, and then we'll go down to specific CVI, as we call them, which is close visual inspection of the areas we're going to inspect, which won't be every single part of the offshore structure. It'll be a certain percentage which is determined by the engineers beforehand. Wow. And that's determined through all the technology they have about cyclic loading and points of pressure on the structure. And then what we'll do is we'll usually use a tool called an ACFM, which is alternating current field measurement. And basically for the diver, it's really easy for us. It's just a small probe that we hold in our hand, and then we can run that across wells, and that goes to the surface. The data immediately goes to the surface to a engineer who is a ACFM engineer, and then he can then interpret that data. If we find anything, any crack light indications as we call them, which ACFM can detect, surface breaking cracks and measure the depth of them. If we find any, then we'll normally follow up with something called MPI, which is magnetic particle inspection, which usually we do at night time. It can be done in the day as well, but we usually do it at night time using ferromagnetic ink and particles, and that can then detect any surface breaking defects, crack light indications, but can't measure the depth of them. Generally, that's a normal inspection campaign.
Wow, sounds very exciting. It's very interesting and insightful for people that don't know much about the diving industry. So thank you for answering that for me. What sort of challenges do you face on a day-to-day basis?
Challenges for us? I mean, there's a lot of challenges that we face. It sounds quite easy, just to nip under the water and do a bit of inspection, even if it's shallow, but it's really not. We normally work from vessels called a DSV, dive support vessel, and you can have up to 100 odd people living on that vessel, and it's all purpose built just for diving. Everything has to run smoothly with the vessel and with the weather conditions, with the current, with the waves, with other vessels in the area, because production is still going on with oil and gas. It's 24 hours, so there's other vessels moving around the area, there's helicopters moving around the area, there's FSOs and big tankers moving around, so we have to try and fit into all these different scheduling of everybody else and ensure that we can run a smooth and efficient diving operation while all this is going on, and make it safe as well. And we have other factors as well, such as I mentioned current. A lot of the time we can't dive if we're in a very tidal location, especially around spring tide. It makes it quite impossible to dive, and also the depth is a massive factor. So IMCA regulation, which is IMCA is the overarching governing body for diving, the International Maritime Agency, and they determine anything over 50 metres has to be saturation diving. But you normally find in the North Sea, in the UK sector, it's normally after about 20-30 metres it's all done, saturation diving, which then poses a lot more risk and potential hazards in the place of doing.
Yeah, well, that does sound quite dangerous. The technologies that are existing in the dive industry, what would you say their benefits and flaws are, as well as their uses?
Yeah, there's a lot of things we use. We use ultrasonic testing meters, gauges. normally Cygnus, that's the brand name, and bathychrometers, CP, cathodic protection meters as well, ACFM, which I'd mentioned before, MPI, A-scan, flooded member detection. We use a lot of things. There's not a one-stop, single good, perfect inspection tool that we use. We have to use them all combined together.
Okay.
But ACFM, as I mentioned before, it's one of the newest technologies we use for non-destructive testing underwater, and it proves to be very efficient. We can cover a vast area using ACFM in quite a small amount of time compared to the other methods. But then it's limited. Pardon me. It's limited because it can only find and measure surface breaking defects. So if it's not a surface breaking crack, for example, it's not going to find it, and it definitely can't measure it. So it depends what we're inspecting, what we're looking for, and that comes into trends and pattern analysis and identifying, and obviously the inspection before, the general visual inspection and the close visual inspection of what we can actually find if we find anything, and ensuring that that's done correctly.
Wow, it sounds like a very intricate system. Where do you see the industry in 5 years from now?
5 years from now, if we think how long we've been using the technologies that we have, and obviously I think we're all quite aware of the modern world, technology seems to be developing in leaps and bounds on a daily basis. So I wouldn't be surprised to see new technologies being introduced within that 5-year period that you talk about, which will enhance what we already have already.
Okay. Paul, would you mind telling us a bit about ROVs, what their benefits are, and how they can compare to divers, and the difference, and how divers and ROVs could benefit from using new technologies?
Yeah, so ROVs are a remotely operated vehicle, a little bit like the Predator aircraft, which are used by the military. So it's unmanned, and you basically have a pilot which sits at a desk. With the ROVs, that's on the vessel that it's operating from. And the ROV can be anything from the size of this desk, quite a small ROV, to what we call a working class ROV, which can be quite large, the size of a car or 2 cars, pretty decent size ROV. And they basically go around, they do similar roles to the divers, but they're a lot more limited in what they can do. They don't have the sensors that we have, and they don't have the dexterity of looking and moving and positioning their hands around corners and using all their senses under the water. Sometimes they can have inspection equipment on them, such as a CP meter, cathodic protection, so they can measure the cathodic protection of a structure, and anodes that are on the structure as well. But they're a lot more limited than divers for their ability to work. But then on the positive side, they can dive usually in stronger currents than divers, and because it's manned by an operator who's at a desk, he's not obviously under as much physical strenuous activity as a diver. So then we can probably, depending on the job, use an ROV for a lot longer in the water than we can divers. We could burn out a whole dive team and the ROV could still be in the water.
Okay, great. I think this brings me on to my next question. How does the industry record rhythms, patterns, and the environment?
Okay, yeah. That's normally done by somebody like TWI. I can actually show you. TWI is a training agency where we do our certification, our CSWIP courses to be inspection divers. So this is one of the training documents they've actually produced here. This is a training document for the CSWIP 3.1U training course that's issued in September 2007. And it's basically got the general trends for marine growth. On this side you have soft fouling, and then this side you have hard fouling. So it tells you the depths of where they're normally found and the density compared to the other depths. So on the left we've got bacteria, and you can see 0 to 40 meters, that's 40 meters there. It's quite heavily dense with bacteria, but you can also find bacteria deep as well, down past 100 meters. However, algae, pretty much at 20 meters is where most of the algae stops. You can find it at about 30 meters, but it won't be a lot. And you can see that chunk there, that's quite dense. Sponges, again, very similar to bacteria. You just have a lot more from 5 meters up to the surface. sea squirts and hydroids are pretty consistent all the way down past 100 meters. And then we go on to hard fouling. The big yellow blob we can see here, that's mussels. And if you look towards the splash zone, we call the watermark line the splash zone, you can see it's very highly dense with mussels there. And the deeper you go, even past 10 meters, it reduces, 20 reduces, down to 40. So if you do a deep dive, like a saturation dive, it's highly unlikely you'll see mussels down there. You might see some broken shells of dead mussels that have somehow found their way down. And then barnacles as well, more densely populated towards the splash zone area, and they get less and less and less the deeper we go down. And tube worms as well. And then you can see they've compiled all this information together to show you roughly what the growth would look like at different depths. So that's 0, 50 meters, 100, and then past. Obviously, the more towards the splash zone and the surface.
Great, thank you. Do you think that the diving industry could stand to benefit from industry social network tapping into technologies such as Google location services?
I think it's probably not for the industry, or maybe it would be for the industry, but more for divers, yeah. If divers were aware of where the jobs were, because at the minute it's quite an old-fashioned system that is used, and it's used more of because we work per project, so we never know when a project's going to start. So we normally find out about work either through a company, through their LinkedIn profile or Facebook page, or through a friend who works for that company. So we always have to keep in contact with people to try and find out where the work is. But if there was something like you suggest, I guess it would be easier. We have a one-stop website, for example, or some kind of application where we could log in and we could see where the work was. It'd be a lot easier to find work.
Okay, that's great. Thanks, Paul. Do you see potential for technologies such as sensor nodes for recording data? Dr. Jamie Lauret Murray, who works at the Coastal Research Institute in Valencia, Spain, he's been conducting some research into data collection, storage, and retrieval by underwater sensor networks, as well as working with things like underwater sensor nodes, underwater sensor networks, UWSNS, underwater wireless sensor networks, and underwater sensor communication, to measure things like salinity, conductivity, turbidity, pH, oxygen, temperature, depth, etc. Do you think the industry could stand to benefit from a technology such as this?
Oh, definitely. I think everything, as we know, the more we live on Earth, we understand how technology is ever improving every day, and knowledge isn't what we thought it was 10 years ago. We move on, we develop a greater understanding and greater depth of knowledge in our fields. So any new technologies that we have to use for our benefits, it can only be good for the industry, really.
Okay, great. So like an internet-work connectivity, sensors, using this as a tool to allow divers and ROVs to be able to capture information, let's just say via images, and relay this to something like a 3D printer, so that engineers can inspect structures, damaged sections or vulnerable sections personally via a 3D object. Do you think something like this has a lot of potential in the industry?
Definitely, yeah. To be honest, until you mentioned it then, I've never really thought about it. But if that kind of technology is available, which I assume in the next few years it probably will be, then it can only enhance what we're doing and make it easier for, like you suggested, engineers to understand what's actually wrong down there and physically see the structure that has a defect in it or whatever the problem is. They can physically see it, they can print it off using a 3D printer. Definitely, I think it can only help us a great deal, to be honest.
Well, that's great. Thank you very much for your time, Paul.
Yeah, thank you, mate.
All the best.